So I want to make this quick video on graphing logs. And if we look at this question on the practice test, the way they're going to ask it is for you to plot 4 easy points to log base 2 of x. So the easiest way to graph would be to graph the inverse. So what is the inverse of log base 2 of x? The inverse of log base 2 of x is y equals 2 to the x power. That's the inverse of log base 2 of x. So the shortcut is to simply cover up log, and then it looks like it says y equals 2 to the x. That's the inverse, y equals 2 to the x. Now, that's the shortcut, but in reality, you could switch the x and the y, then solve for y. So if I were to switch the x and the y and solve for y, it'll say x equals log base 2 of y. And then you would want to get y by itself, so you'd want to get rid of the log base 2. So you would raise both sides to become powers of base 2. That way this eliminates, and you will have 2 to the x equals y, which is y equals 2 to the x. So you don't need to show this work. You could just do the shortcut by covering up the log, and then it kind of looks like y equals 2 to the x. That's the inverse of it, okay? So anyways, what was the process on actually finding the inverse? It's switching x and y. So what we're going to do is we're going to graph this inverse, which is over here, by making an xy table for it, okay? So when we make an xy table for the inverse, it's really easy because this is an exponential growth function that we've done before, and you would use the coordinates -3, -2, the inputs -3, -2, -1, 0, 1, 2, 3, and then you plug in the easiest number 0. 2 to the 0 is 1, and then from there you could make your outputs grow by that growth factor of 2. So the 1 then becomes 2, and then the 2 times 2 is 4, and then 4 times 2 is 8. So it is growing by the growth factor of 2. 1 times 2 is 2, times 2 is 4, times 2 is 8. Backwards, it's multiplying by the reciprocal of 2, which is 1/2. So if you're multiplying by 2, going backwards, it's dividing by 2, or multiplying by half. 8 times half is 4, times half is 2, times half is 1, times half is half, times half is 1/4, times half is 1/8. And I hope we understand that it keeps getting smaller and smaller. 1/16, 1 over 32, 1 over 64, keeps it getting smaller till you get, or infinitely approaching 0, but never actually getting to it. So anyways, these are the coordinates of the inverse function. This is an exponential growth function. If I were to graph this inverse function on an xy plane, it would look like this, exponential growth function. Okay, but this is not the graph that we want. This was the inverse of the logarithmic function. So if I wanted to graph this one, well, all I need to do is take these coordinates, especially the nice ones, and all I need to do is switch the x and the y back. So the 1, 2, you're going to switch it back to 2, 1. The 2, 4, you're going to switch it to 4, 2, and the 3, 8, you're going to switch it to 8, 3. So I'm going to go over here, and I'm going to switch those coordinates. I'm going to put the coordinates in yellow. Why not? I'll use green. So 2, 1 instead of 1, 2, 4, 2 instead of 2, 4, and 3, 8. 8, 3, I'm sorry, instead of 3, 8. Now, if I did, well, I guess I could do 1, 0 and switch it. That'll be a 1, 0 instead of 0, 1. Now, if I did the -1 and half, switch that, that'd be half and -1. You're not going to be able to do that on the quizzes. So just with those 4 points, you'll be able to see your graph. It says plot 4 easy points, and those are 4 easy points. So you're just going to, with your cursor or with your mouse, click on the location of 1, 0, which is right here. Then you would click on the location of 2, 1, which is right there. And then 4, 2, which is right there. And then 8, 3, which is right there. Now, you cannot click on the halfway points, but I hope you see that the graph is coming like this, and then it would be 1 halfway out and then down -1. So it would be right here, further, closer, closer, infinitely approaching the y-axis, which is the asymptote x equals 0, okay? But that's all you do. You plot these points right there, and you hit submit, and that'll be the correct answer. But technically, the actual graph, it keeps getting closer and closer and closer, infinitely closer to this asymptote, and the asymptote is x equals 0, okay? So your graph would look like this. But all I asked you to do on this question was to plot 4 easy points, 1, 2, 3, 4, and you get full credit. Let's look at a different one. Now this one was easy because the original question was y equals log base 2 of x, and all we did was find the inverse, which was super easy, 2 to the x, and then we got those coordinates and switched them to get our actual coordinates to this. Now it would be a little bit more complicated if you had an h and k shift. Remember, h is always being subtracted from x, in parentheses. The k value is always being added or subtracted at the very end. Okay, so let's look at one of those that actually do have an h or k shift. So we have this guy that has a h and k. So what is the h value? -2, right? So we have h equaling -2, and the k value, +1, okay? So once you identify h and k, you could ignore h and k, all right? So you could focus in just on this part of the graph. So is graphing that, I mean, if I ignore this over here, is graphing this pretty easy, log base 3 of x? Yes. Why? Because all you got to do is graph the inverse, come up with the input-output table of the inverse of log base 3 of x. So when we do that, we make an input-output table of that log base 3 of x, but of the inverse of it. So what is the inverse of log base 3 of x? What is the inverse of log base 3 of x? Here's a hint. If you cover up log, what's the inverse? Y equals 3 to the x, right? Now, if you were to show the work by switching x and y, switching them and then solving for y, getting rid of the log base 3 by raising it to be the power of base 3, and then this would be an x, you raise it to be the power of base 3, you would get y equals 3 to the x power. So it's easier to just cover up log and you have y equals 3 to the x. That is the inverse. So I'm going to write that down right here. Y equals 3 to the x. So this is the inverse. I'm about to do the coordinates of that inverse. I'm going to go -3, -2, -1, 0, 1, 2, 3. Plugging in an easy number like 0. 0 right there. 3 to the 0 is 1. And then I could now make that answer, that output, I can make it grow by 3. Okay, so that 1 times 3 will get me to the next output, which is 3 times 3 is 9 times 3 is 27. Going backwards, it's dividing by 3, which means multiplying by 1/3. So you get a 1/3, you get a 1/9, and a 1/27. Now, as long as you know that the values are getting smaller and smaller and smaller infinitely this way, and getting bigger by multiplying by 3 this way. Anyway, these are the coordinates. These are the coordinates of y equals 3 to the x. These are the coordinates of y equals 3 to the x, which is the inverse of y equals log base 3 of x. So if I actually wanted my coordinates of y equals log base 3 of x, all I need to do is switch those guys to a 1, 0, switch these guys to a 3, 1, switch that to a 9, 2. Get it? And now we're able to graph it. But that's if h and k didn't exist. And we do know that h and k exists, right? We actually stated what h and k is. Whoops. I can't remove that rectangle anymore. Sorry. But anyways, we already know that h is -2 and k is 1. So let me write that again. h is negative 2, which means 2 to the left, and k is positive 1, which means 1 up. Now, if you're on a graph, you could see that you shifted 2 to the left and 1 up. But if you're not on a graph, if you are working with coordinates before graphing, then you might as well subtract 2 from the 1, right? Subtract 2 from the 1, and that'll be a negative 1. And then add 1 to the 0, and that'll be a positive 1. Does that make sense? Because if you were at the coordinate 1, 0, and you shifted 2 to the left and 1 up, you'd end up at this location. But it's easier to just subtract 2 from the x, add 1 on the y. So subtract 2, that gives you a negative 1. Add 1, that'll give you a positive 1. Subtract 2, what do you get? What's 3 take away 2? Is 1, okay? And then add 1 on the y. So add 1 on the y. 1 plus 1 is 2. And last but not least, let's subtract 2 on the 9, which gives us 7, and add 1 on the y value, on the k, which will give you a 3, correct? And ladies and gentlemen, those are coordinates, and you need to put 3 easy points. Well, right here it says 4, but it should be 3, because the other ones will be fractions and you won't be able to get them. So anyways, let's plot those points. Negative 1, positive 1, that's right here. And we go to 1, 2, 1, 2, that's right here. Then we have 7, 3, that's right here. Now, that's what you would plot, you get full credit, but where would the asymptote be at? Where would the asymptote be at? The asymptote would be the vertical line x equals negative 2, okay? X equals negative 2. So if you were graphing, you would have a asymptote right here at negative 2, which means that your graph would infinitely approach but never actually touch. So that's what your graph would be if you were graphing it on paper. But for this quiz, all you need to do is plot these 3 red dots, and you should get full credit. But I guess it's important to talk about the comparison of exponential growth functions and logarithmic functions. So on an exponential growth function, before we even get to this example, on an exponential growth function, you have something like y equals a, parenthesis, the base, to the power of x minus h, and then plus k. And we know that the h and the k are the shifts, right? And we also know, like for example, y equals, let's do a simple one, 2 to the x. Let's not put an h shift, but let's put a minus 3. What does that look like? On the xy plane, we know that this is an exponential growth function because the base is 2. And we also know that the asymptote is y equals k. Y equals k on an exponential growth function, which means the asymptote here is y equals negative 3. So if you go to the y-axis to negative 3 to 1, 2, 3, it's going to be right here, the asymptote, okay? So this is an exponential growth function. What does it look like? It looks like this. From that asymptote, it ends up growing left to right. And that's just a review of what we did last time on the quiz, exponential growth or exponential decay, depending on your growth or decay factor, the b value. Now, when we compare this to logarithms, you have y equals a log base b to the x minus h plus k. You still have your h with x, but over here h was with the x up here, and the k value is still at the end being added or subtracted, okay? So on a logarithmic function, your asymptote ends up being x equals h, okay? X equals h. As opposed to on an exponential growth function, your asymptote was y equals k, which produced a horizontal line. right here on the logarithmic function, your asymptote will be x equals h. So whatever you see here, think opposite to name that h, and that'll produce a vertical line. Okay, does that kind of make sense? I hope so. Let's move this to the side and use that knowledge on this question right here. So what is the asymptote of this logarithmic function, log base 2 of x minus 3 plus 5? The asymptote will be x equals positive 3. So yeah, when you graph it, your x value at 1, 2, 3, you're going to have an asymptote right there. Okay. So it'll probably look something like this. I'm not too sure, but it'll probably look something like that. But if you actually wanted the coordinates that produce the graph that lead up to that asymptote, what you would do is ignore h and first identify h and k, ignore h and k, graph the inverse, which is y equals 2 to the x, and then switch your coordinates, plot your coordinates, but shift them 3 to the right and 5 up. So that would produce this graph right here. Anyway, there is going to be a question that says state the asymptote. They give you that, super easy. It's just x equals the opposite of what you see here, x equals positive 3. That's the asymptote.